Okay, now so we're going to use the geometric mean theorems for right triangles to solve some problems. And I'm going to do some selected problems from your worksheet. I just thought I'd review the two theorems first. So we have the altitude geometric mean. The altitude is the geometric mean between the two segments of the hypotenuse. It's in words right here. So here it is. The altitude is f. The two segments of the hypotenuse are d and e. They go in the square root. You can work it with this formula or the proportion that leads to that formula. F times f, d times e. We cross multiply, f squared equals de, or f is the square root of de. You can use any of the three formulas that you feel comfortable. You will probably notice me using this one the most because I never know where my variable is going to be. So the variable could be here or it could be here and here, which would mean I would have to square both sides. So I use this version of the formula. That's my favorite. Then we have the leg geometric mean that says the leg is the geometric mean between the entire hypotenuse, that's C, and the adjacent segment. So we have the leg of A, it goes twice, and then the entire hypotenuse and D, so A and D go together. The other leg geometric mean, this leg goes with this part of the hypotenuse. You have to have the altitude drawn to make the three similar triangles and to break this up into the segments that work. Any other segment in the right triangle will not do a geometric mean. It must be an altitude. That's how you get three similar triangles. So you will see me using these. These are my favorite. I like the proportions. I like to cross multiply. I think it's the easiest one to work with because of regardless of where the variable ends up, it's just as easy to solve. You use the same process. 6 and 1/2 a dozen the other, doesn't matter. So here's our worksheet. I've selected some problems to do. I'm going to do 1, 6, 8, and 10 on this side, work them out for you, and 1 and 5 on this one, but then I will provide a complete worked out answer key for everything. Number 1 says, what's the geometric mean between 8 and 12? In other words, in your geometric sequence, there's a number, there's a number missing. It's supposed to be 12. Let's start fresh. 8 and 12. As I was saying, in the geometric sequence, there's a number missing. So, there you go. That's why you had to learn that these were called the means and these were called the extremes back when you read the book. See, the means are in the middle when you write the proportion that way. It really doesn't matter because the truth is, as long as the cross product's the same, you're going to get the same answer. So I won't be quizzing and testing on what's called the means and what's called the extremes. Okay, so here we go. If we solve this, x squared equals 8 times 12. Okay, so in this case, we are going to do the square root of 8 times 12 to see what the answer is. That's 96. Okay, I'm going to do a radical and a decimal answer. Just to, get it closest. That's 4 times 24, which is 4 times 6. So it's going to be the square root of 4 times 4 times 6. The square root of 4 times 4 is 4. And 6 is 3 times 2, so it's not going to break down anymore. The square root of 96 is approximately 9.8. And just to check that I did it right, I'll do 4 square root of 6. Make sure I also get 9.8. So there's your answer. Okay, so that's the first one. Now let's work number 6 from the worksheet. You have this right triangle. And you have to decide if you're going to use the leg geometric mean theorem, the altitude geometric mean theorem, some combination of both, and which one should you use first? Well, you should use the one that you have the most information for. I have the two segments of the hypotenuse. I want the altitude, so I'm going to go ahead and do that first. The altitude is the geometric mean. It goes twice in the proportion between 8 and 23. So x squared equals 8 times 23. 8 times 23 is 184. 4 times 46. 2 times 2 times 2 times 23. So it's going to be 2 roots of 46, which is approximately 13.6. So we got x. Now let's get y. Well, there's two ways we could get y. We could use x and 8 and y and do a Pythagorean theorem. But because we need to practice geometric mean, I'm going to do geometric mean. The leg, this is the leg on the big right triangle, is the geometric mean between the entire hypotenuse, in this case 8 and 23 is 31. Oops, I put that in the wrong place. And the segment of the hypotenuse adjacent to that leg. Well, there's an 8 and a 23, but 8 is adjacent to the y. So I have y squared equals 31 times 8, which is 248. Square root both sides. 248 is 4 times 62. Looks like it's just going to be 2 roots of 62, which is approximately 15.7. Okay, so we got y, we got x, y. Now we need z. Z, we're going to do another geometric mean. Z is the geometric mean. It's a leg, so it's between the entire hypotenuse, which is 31. And then this time the adjacent segment to the z is the 23. Z squared equals 31 times 23, 713. Both of these are prime numbers, so their product is a prime number. Not going to break down that radical. 26.7. So I ended up using all three geometric means. I could have done some Pythagorean theorem, but I wanted to practice with the geometric mean. So that was number 6. I don't like using this big marker, but you can see it better. So that's why I'm using it instead of a pencil. Number 8. Although the marker's starting to lose all its ink, I may have to switch. All right, so we're going to find x, y, and z. I don't have this leg, not asked to find this leg, so I'm not going to be doing a leg geometric mean with that leg. I have this leg. By the way, these are arbitrary. This leg is the geometric mean between 2 and the entire hypotenuse z. That would give me 2 variables to solve for in one equation, so I'm not going to do that. I'm going to do the altitude geometric mean, which says the altitude is the geometric mean, so it goes twice. This time it's not a variable, between the 2 segments of the hypotenuse. So 9 equals 2x, so x is 4.5. That was easy. Okay, so if x is 4.5, z is just the sum of those two, so z is 2 plus x. 2 plus 4.5, 6.5. No problem. Okay. Now to do y, I'm going to do the leg geometric mean theorem that says the leg is the geometric mean between the entire hypotenuse, which we know is 6.5, and the segment adjacent to that leg, which in this case is 2. So if I solve that, y squared equals 2 times 15, which is 13. Now technically it's plus or minus 13 because I'm square rooting both sides, but we know that you just take the positive because we're doing lengths of segments. So that's number 8, all worked out. You should be able to do the other ones now. Yeah, I forgot. I wanted to do one where you had to name the 3 similar triangles. So I'm going to go back and do number 4. I hope you can't hear my son screaming in the background. Okay. So we're going to name the 3 similar triangles, keeping in mind that, let's say this is the smaller acute angle and this is the larger one. Okay, which means the smaller acute angle would be recreated here because these have to be complementary. The larger acute one would be recreated here for the same reason. And I just want to remind you, when you name the triangles, you have to go in order of matching angles. So I saw that problem on your papers. So in the big triangle, let's call it VUT. Okay, so I went from V, which was the one arc, to 2 arcs. I have to do the same in the other triangles. Let's do the medium, Mama Bear. V, I went V to U to T in the big one. I'm sorry, I went from the 1 arc angle to the right angle. So in this one, I would go V, A to the right angle, and then U. And then in the baby triangle, I'm going to go from the 1 arc angle to the right angle to the 2 arc angle. So U, A, T. So however you name the first one, make sure that you match the other ones up similarly. Haha, pardon the pun. All those triangles are similar by angle similarity. Okay, now let's do the word problem. Those are your favorite. I'm going to read the problem and draw a picture as I read the problem. We have an airport, which I'm going to denote with A factory, and a shopping center are at the vertices of a right triangle formed by 3 highways. Well, of course they are. The airport and factory are 6 miles apart. Their distances from the shopping center are 3.6 and 4.8 miles, which means since the airport and factory are the largest distance apart, those are the hypotenuse. Okay, so I'll make the airport. This is not going to be to scale if I do it that way. The airport and factory are 6 miles apart. Their distances from the shopping center are 3.6 and 4.8 miles. So this is 3.6. It's the smaller one. And 4.8 is the larger distance. I realized I need to switch those. Okay, so that's that picture. The service road will be constructed from the shopping center to the highway that connects the airport and factory. So basically, okay, you're going to want that to be the shortest road possible, cheaper to construct. So it's going from the shopping center to the airport factory. If you don't get this picture, you know you're not doing it right because that's the theme here. Okay, what is the shortest possible length for the service road? Round to the nearest hundredth. Okay. So, it looks like in order to find this length, I would either have to do a Pythagorean theorem on either the medium or the small triangle, or know the 2 segments of the hypotenuse. I have neither right now, but I can find one. I can either use the 3.6 and find, let's call this x, because it's the geometric mean between the entire hypotenuse, which is 6, and x. Or I can use the 4.8 and say find a y, doing that leg geometric mean theorem. I'm going to go for this one. So the leg of the right triangle is the geometric mean between the entire hypotenuse and its adjacent segment. So there's my proportion to solve. 6x equals, I'm just going to go decimal this. If there's decimals in the problem, I'll work at all decimals. But I'm going to carry it out as far as I can to be as accurate as possible. That's not right. I divided it by 2 instead of 6. Let's try that again. X is 2.16. Okay, so that means this is 2.16. So to get y, all I have to do is subtract from 6. 6 minus 2.16 is 3.84. So now to get the length of the service road, I'll call that z. The altitude is the geometric mean between the 2 segments of the hypotenuse. And I'll solve that. 2.16 times 3.84 is 8.2944. Square rooting both sides, and I'm going to take the positive because it's a segment length. 8.2944. It's not too many decimals to carry it along. Wow, that came out exactly to 2.88. So the service road is about 2.88 miles long. Great, now they'll know how much asphalt to order. Okay, so that's the end of that side. Let's do a couple of problems from this other word problem worksheet. I'm going to do number 1 and number 5. Number 1. Wilma has a rectangle of dimensions L by W. She would like to replace it with a square with the same area. So we want the area of the rectangle to equal the area of the square. Well, look at that. It looks like a geometric mean. What is the side length of the square with the same area as a rectangle? Well, if you want a one side length, you're going to have to square root to get what x is. So basically, the length of the side of the square would be the geometric mean of the dimensions of the rectangle. So the length of the side of the square is the square root of the length times the width on the rectangle. Oh, that's nice. All right, number 5. Cliffs. I don't know why this big line came up in the worksheet. Oh well, can't help it. A bridge connects to a tunnel as shown in the figure. It's nice when they draw the figure for you. The bridge is 180 feet above the ground. They've got that on there. At a distance of 235 feet along the top of the bridge. The angle to the base and summit of the cliff is a right angle, which means we have an altitude and a right triangle. We can do the whole geometric mean thing. So I'll draw a bigger version of this picture because I'm not going to be able to scan in and point on that. So this is 235. We'll keep in mind everything's going to be in feet. This vertical distance is 180, which means this is 180 on that. This is D, this is X. At some point we're probably going to have to find them. And this is H. Okay, great. Part A. What is the height of the cliff round to the nearest whole number? Well, in order to get the height of the cliff, I need X so that I can add it to the 180, which means I'm going to start by solving by X, which means I'm going to do the altitude geometric mean theorem. Oops, this should be 235, 235. Geometric mean between the two segments of the hypotenuse. Okay, 235 times 235 is 55225. I'm going to divide that by 180. X is approximately, I'm not going to do 306.805 repeating. Okay, we can round that off a little bit more, and that's in feet, which means the height is approximately 180 plus 306.8, which is approximately 486.8. So that's part A, 486.8 feet. How high is the cliff from the base of the summit? The angle to the base and summit of the cliff is a right angle. Well, that's the same answer. Yeah. If this is the base and this is the summit, it's H, approximately 486.8 feet. I guess they're just making sure that we understood the words from the problem related to the side on the figure. What is the value of D round to the nearest whole number? Well, if I look at my easy picture, this is D. We know that this is 306.8. We could either do a geometric mean with the leg of the hypotenuse, the adjacent segment, and the whole thing, but that's got 2 decimals in it, so I'm not going to do that. Or I could just do a Pythagorean theorem right here, which I think I'm going to do that. D squared equals 306.8 squared plus 235 squared. Okay, so if I add that up, it is going to be a ginormous number. One, 149,351.24, and I'm going to square root that. D is approximately 386.5 feet. 386.5. That makes sense because it should be the longest side because it's the hypotenuse of a right triangle. Oops. Alright, so that ends this video. I did the problems without reading them ahead of time on purpose so that as I discovered and drew things and drew stuff, drew conclusions from the wording, you could see how that thought process goes about. The next video, I'm going to show you one of the things that will be on the test, which is how to prove the Pythagorean theorem using the geometric mean, because that is one of the standards you have to know.